Okay, we're going to continue our notes in Chapter 8. This time we're going to talk about decay or depreciation. So what that means is instead of the money going up or the value going up, whatever it is going up, it's going to go down. So the only big difference is so far everything we've been doing is initial value. So if it's growing, it's that initial value times 1 plus whatever the percent is to n. Well, if it's decaying or going down, and the easy way is if it's going down, it's a decay. The only thing that changes is 1 minus the percent of n. Okay? So, it's still, A is still the initial value, percent, change it to a decimal, n is for the amount of time. So Jackson just purchased a new car for $25,000. If the car depreciates in value at a rate of 8% a year, how much will the car be worth in 10 years? So starting with A, my A is 25,000. My percent is 8%, but I got to change that to a decimal, and that would be 0.08. Remember, to change your percent to a decimal, you either can take, there's two things. You can divide it by 100, or since this is 8%, my decimal's here, and you can move it twice and just fill it in with a 0. And this time n is equal to 10. Just put everything into the equation. So 25,000 times 1 minus 0.08 to the 10. Simplify in here first. Pull up my handy dandy little calculator here. All right, so 1 minus 0.08 is 0.92. By the way, guys, that 0.92 is your multiplier. That is your multiplier. The 8% is your interest or your percent, but then 0.92 is the multiplier. Okay, 25,000 times 0.92 to the 10th power. So the car will be worth $10,859.71. Again, we're talking about money. We're not always going to be talking about money, but if we're talking about money, you always go out 2 decimals. Okay, so that's how much the car is worth. All right. I'm going to move this over. Professor Pietro has just developed a new Super Ball, and you have been asked to test its rebound capabilities. From your experiments, you've recorded that it will drop from a height of 250, so that's the starting height, and the first bounce is at 210. All right, so we're going back to rebound ratio. So if you remember rebound ratio, that's the first bounce, so that'd be the 210 divided by the starting height. So 210 divided by 250, and I get 0.84. So that's our rebound ratio. That means it's rebounding 0.84 amount of the time. Predict the height of the ball if you dropped it from 25 feet. So that means instead of it being 250 centimeters, we're going to do now 25 feet. The rebound ratio is still going to be the same because the ball hasn't changed. So I'm going to take 25 times the 0.84. And so the first bounce would be 25 feet. Part C, write an equation for the bounce heights of the ball after n bounces if it's dropped from the initial height of 575 centimeters. According to your model, how high will it be after the 12th bounce? So remember, our equation looks like this. T of n equals A times our rebound ratio to the N. Well, our initial is 575. Our rebound ratio is that 84 to the nth power. So the first part is we need to write the equation. So there's our equation. So that's part A. Part B now is the 12th. So we want T of 12. And that's going to be 575 times 0.84 to the 12th. Put this in our calculator. And we get, it'll be about 70.9609 centimeters. Okay, so that's growth and decay. So those are those notes. All right, once you can try to do your assignments, or you can practice through those other worksheets and things that are on the school closure folder. If you have questions, let me know.